Okay, today we're covering the law of cosines. So to bring it back together with what we did yesterday, we covered the law of sines. And when you know an angle and its opposite side, of course with another angle or side, then the law of sines can be used to solve the triangle. But of course sometimes you're not going to have that information, and if not, then we're going to be able to use the law of cosines. So that's what we're going to talk about today. We're not going to derive it. We're just going to go with the formula and use it. So to start off with, we have our triangle ABC and their sides opposite. And what the law of cosines says, if you look at this first form, a squared equals b squared plus c squared minus 2bc times the cosine of a. These two are always have to be the same letter. So hopefully you realize that's a side and the angle opposite the side. So that's what you're going to be looking for. Um, Another variation of it might be b squared is equal to a squared plus c squared minus 2ac times the cosine of b. Or yet another one, c squared is equal to a squared plus b squared minus 2ab cosine of c. So the gist of what we have is we know two sides, like if I'm looking at the last one, if I'm looking for side C and I know A and B, and then I also know the angle in between those two sides. Alright, so let's go do some of those problems. Keep in mind when you're trying to remember this, however you choose, this right here looks a lot like the Pythagorean theorem that you're familiar with. So if you want to remember this form of it, that's c squared equals a squared plus b squared. The two sides always go with what two sides that you have here. So it's the minus 2ab. I have a and c here. It's going to be ac. I have b and c here. It's going to be bc. And as we just mentioned, the angle that we're taking the cosine of is always opposite the side that we're looking for. So we have the length of two sides of a triangle are 8 and 10, and the measure of the angle between them is 40 degrees. Again, this is the angle between them. And pick a formula, doesn't matter which one. I tend to remember the first one more, but it does not matter. So I have a squared equals b squared plus c squared minus 2bc cosine of a. So we're looking for the side opposite angle A. My two sides that I know are 8 and 10. So we have that much of it, 8 and 10. And then the angle between those two sides is 40 degrees. So hopefully you're good at putting this whole thing in your calculator and you find out that a squared equals 41.43. That's a good stopping point so that if we have any trouble, we can figure out where the trouble is and then take the square root of that. Of course, it's plus or minus, but we can't have the negative side length of a triangle. So we go with the square root of 41.43, which is 6.4. Okay, so this was an example of using a triangle where I knew two sides and the included angle. Okay, another time that the law of cosines is helpful is when we know all three sides. So this would be side, side, side that we're looking at. The length of the sides are 10, 14, and 15. What is the measure of the angle opposite the longest side? Now, if they don't give you a specific side and you have to find all of them, you always want to start with the longest side because then you will know right away whether or not you have an obtuse angle in your triangle. So we're going to start off with 15 squared equals 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of, and it doesn't matter which one, A. We're just going to call it A. Okay. Now, I like to go ahead and put this in calculator ready form before I pick it up. So I'm going to subtract these two items. So it's going to say 15 squared minus 10 squared minus 14 squared. And then hopefully you can understand that this part right here is being multiplied by the cosine of A. So I'm going to divide it, negative 2 times 10 times 14. And all of that is going to be equal to the cosine of A. So punch that in your calculator and we're down to that point again where it's just a good intermediate step to figure out if you're doing anything wrong. And you get 0.2536. And of course you have to use the inverse function to find out what that angle is, or the second button on your calculator gives you the inverse cosine. So when you do that, you find out that angle A is going to be 75.3 degrees. Okay, moving along. Sometimes we have to use the law of cosines followed by the law of cosines again, or the law of sines to completely solve the triangles. So here we have an example of that. I have triangle RST, and I'm going to go ahead and draw it out. I realize some people don't need to, but I think it does help a lot. Alright, so I have RST. Side S, opposite angle S, is 41. Side T, opposite angle T, is 53. And angle R measures 126 degrees. And we are looking for the measure of angle T. So you can see that this is two sides and the included angle. So I am going to I have to use the law of cosines, and the law of cosines is going to give me this side, which is little r. So before I plug them in, I'm going to write the formula with r, s, and t. So I have r squared equals s squared plus t squared minus 2st cosine of r. So r squared equals, oh, what's s? S is 41 squared plus 53 squared minus 2 times 41 times 53 cosine of r, and r of course is 126. So we put that in our calculator and we find out that r squared equals 7044.5147. You don't need to carry it out that far, but we did. And we take the square root of both sides. R is plus or minus 83.93, but we only need the positive because we're dealing with a triangle. Now from here, so I know now that R is 83.93. Oops, that didn't come out right. 83.93. So now I can use my law of sines. I have an angle, side opposite. I'm looking for that angle and the side opposite. So we're going to have the sine of 126 over 83.93 equals the sine of t over 53. My variable that I'm looking for is on top, so I can just multiply both sides by 53. So the sine of t will equal 53 times the sine of 126 all over 83.93. And that means that the sine of t will be equal to 0.5111. Now, if you didn't get that, remember, I have an operation. We have an operation up here in our numerator. So most calculators require that you put parentheses around that top part. So check that again. And again, we're looking for our angle, So we're going to use our inverse function, and that requires the second button or shift key with sine, and you will find out that the measure of angle T is equal to 30.7 degrees. Now that's the end of the examples. I did look through the assignment that I have and work a few more problems just in case you had any trouble with them. Some of the problems that you have to work on are just helping you with flexibility of writing the law of cosine. So I picked an even problem, 22. Basically, it tells you that you need to figure out whether you have to use the law of cosines or the law of sines, and you're trying to find this measure in red, but you only know the information in blue. So again, this is an example of knowing the sides of a triangle, and I'm looking for the angle. So if I know the sides, then that means that I have to use the law of cosines. And I will be using the cosine of c, so I know that c squared will be by itself. And then we just write our variation of the law of cosines. C squared equals a squared plus b squared minus 2ab cosine of c. So that's all those problems are involved with. And the last one is giving you another triangle and just telling you to find all the sides of it. Okay, so we're going to go find all of those. Um, find the remaining sides and angles. Keep in mind that's the same thing as saying solve the triangle. Okay, so I have triangle FGH. I know angle G. I know side H, and I know side F. So I have to find side G. I got to find angle F, and I have to find angle H. So we're going to find all those things, and that means that then we will have finished the problem. So to find G, hopefully you see that means we've got to use our law of cosines. So again, I'm going to write it out. G squared equals F squared plus H squared minus 2FH cosine of G. And that means G squared equals 30 squared plus 35 squared minus 2 times 30 times 35 and the cosine of 110. So we talked about, we put all that in our calculator and we find out that G squared is equal to 2843.242. So you have some idea. And if you're close, rounding may be an issue. Take the square root of both sides, but we own, and it is it is positive or negative, plus or minus, but we're in a triangle, so we only need the positive. So we have 53.3. So G in my answer box is 53.3. I have no label, so we'll leave it at that. But now I know this side is 53.3. So hopefully you can see that we can now use our law of sines. And let's go with the sine of 110 over 53.3 equals, it doesn't matter which one we find, we'll go with um, F. So that'll be the sine of F over 30. Again, my variable's on top, so I'm going to multiply both sides by 30, and it'll say the sine of F is equal to 30 times the sine of 110 over 53.3. And we like to write this step out so we can check ourselves along the way. The sine of F becomes 0.5289. Again, looking for that angle means I need to use the second or the shift key to access the inverse sine function. And we find out that F is going to be equal to 31.9 degrees. So we're left with H, and hopefully that is obvious to you that if I know, so we have down here F is 31.9 And if we know two angles of a triangle, we can always find the third by adding them together and subtracting from 180. Adding them together and subtracting the sum from 180. So we'll find out that our next angle H is 38.1 degrees. If your tenths are off, if they're a little different, it's a rounding issue. Don't worry too much about it, but you should make sure that all three of your angles always add up to 180 degrees when you're solving your triangles. And that's the end of our law of cosines.